Hello friends, here in this video we will see a problem on calculation of moment of inertia for unequal angle section. Here we have that question. Find the position of centroid Ixx and Iyy for an unequal angle section whose dimensions are given, that is 125 mm into 75 mm into 10 mm. Now this is the question we have. So whatever is there, I'll write it in the form of data. Now in the question we have to find the position of centroid. Position of centroid is located by x bar value and y bar value. Next we have to even find Ixx and Iyy, that is mi about x axis and mi about y axis. Then it is given that it is an unequal angle section whose dimensions are in the form of d into b into t, that is here we have depth is equal to 125 mm, width is 75 mm and thickness of web is 20 mm. So suppose here we have an unequal angle section which I can draw it with the help of a rough diagram. Now this is the unequal angle section where we have web and flange. So this 125 mm dimension is of the web, that is the total depth. This is just a rough diagram. I'll draw the diagram again in a more better way. Then 75 mm is the overall width and 10 mm is the thickness. So now once we have understood what is the meaning of unequal section, we can start the problem by drawing this diagram again. So let us get started in the solution part. Here, as we know all the dimensions, we can start drawing the unequal angle section. Now this is the unequal angle section. The dimensions I'll mark over it. (125 mm) is the total depth, 75 mm is the total width and the thickness is given as 10 mm. So now when we are solving the problem of unequal angle section or any given section, in that case the first thing is we should know the location of centroid. Once we know the centroid, then only we can start the problem. And as we can see here, the first question is to calculate x bar and y bar, that is the location of centroid. If they had not asked this, then also we have to calculate the centroid. So moment of inertia calculation will start first with the location of centroid. So for that purpose, here I'll divide this unequal section into two rectangles. I'll call this as rectangle number first and this would be the second rectangle. So now after this, first I should know what is the value of x bar and then y bar. As we can see this unequal angle section, I'll write down, since the given unequal angle section is unsymmetric about both x axis and y axis, So therefore location of centroid with respect to y-axis is given by, the formula is x bar is equal to a1 x1 plus a2 x2 upon a1 plus a2. So here I'll keep this as the first equation. Now I need to know all these values. So area 1 will be, it is, we can say that from 125 if I subtract 10, this much is the height here, that is 115, and width is 10. So area is 10 into 115. So area 1 comes out to be 1150 mm square. And area 2, this will be 75 into 10, that is 750 mm square. Next, x1. x1 is the location of y-axis for the first rectangle, so its y-axis will be at half of 10. So x1 is 10 by 2, that is 5 mm, and x2 is the location of y-axis for the second rectangle up from the y-axis here. So for this the y-axis would be at half of 75, that is 37.5 mm. Now after getting all these values, we can put it in equation number 1 to get x bar. Therefore put all values in equation number 1. So here we have x bar is equal to, it was a1 into x1. So here I have a1 as 1150, x1 it is 5, plus a2 into x2, a2 is 750 and x2 is 37.5. upon area 1 plus area 2, that is 1150 plus 750. So if I calculate from this, I'll get x bar is equal to 17.83 mm, that is from left hand side. So here I have the location of y-axis from left hand side. Next, after getting x bar as 17.83 from left hand side, we can even get its value from right hand side. So from left hand side it is 17.83, from right hand side it would be 75 minus 17.83. So therefore x bar is equal to 75 minus 17.83. So this value comes out to be 57.17 mm from right hand side. Now after getting x bar, I can say that we know the value of y-axis where it is located, so we have to locate it in the figure. So here it is 17.83 mm from left hand side, so this is 10, so it would be more value, that is more than 10 here. So I have to take a value by a judgment in the figure. So here I have the y-axis, location is x bar is equal to 17.83 mm from left hand side and x bar is equal to 57.17 mm from right hand side. So here is the y-axis of unequal angle section. Now in a similar manner we would be calculating the x-axis, because we know that on this y-axis there will be centroid, but at which height that we don't know. For that we should know the value of y bar. So in a similar manner we can say that now, since location of centroid with respect to x-axis is given by y bar is equal to a1y1 plus a2y2 upon area 1 plus area 2. So this I'll keep it as equation number second. So now area 1, area 2 values are known to us. Previously we have used them in the calculation of x bar. Now y1 and y2 values. If I look into the diagram, then the x-axis of the first rectangle, it would be passing at half of this height, which is 115, and this rectangle 1 is starting after 10 mm. So y1 will be 10 plus, because it is starting after 10 mm, plus this is 115. So I have to take half of that, 115 divided by 2. So y1 value, this comes out to be, here we have 10 and this is 115 by 2. So this value, it would be, here in this case it is 115 divided by 2. So that is, this would be 57.5 plus 10, that is 67.5 mm. Next, after this, y2 value, y2 will be the x-axis for the second rectangle, and this would be located at a distance of 5 mm as we see from x-axis. So this is y2. So y2 is half of 10, that is 5 mm. Now after getting these, we can say that put all values in equation number second. So therefore y bar will be a1 into y1. Here I have in equation number 2, a1 it was 1150 into y1 67.5 plus area 2 750, y2 is 5 divided by area 1 plus area 2. So here I will get y bar, and my answer is 42.83 mm from bottom. Therefore I can say y bar is equal to, since I have got the answer as 42.83 mm from bottom, so from top it will be 125 minus 42.83, which gives me the answer as 82.17 mm from top. Now after getting the y bar value, in a similar manner I will be locating the x-axis, whose distance is more from top as we can see. So here the x-axis would be located at 82.17 mm from the top. And from the bottom the value was 42.83 mm. Now, once we have known x bar and y bar values, we can say that we know the location of centroid, and it is located here, that is G. This is the location of centroid. So, our x bar and y bar values, these were our answer number first and second respectively. Y bar was the second answer, and x bar, it was the first answer. Now, after finding x bar y bar values, next is we need to find the MI, that is moment of inertia. So we'll start the MI calculation. MI first about x axis of the angle section, which is here. So I'll say that since MI, moment of inertia for unequal angle section about x axis is given by Ixx is equal to Ixx1 plus Ixx2. So this will be our equation number 3. Now I need to know Ixx1 and Ixx2. So therefore Ixx1 is MI for section first about x axis of unequal angle section, that is we are trying to find the MI for rectangle number 1 about the x axis of unequal angle section, and that is Ixx1 is equal to Ig1 plus area 1 into h1 square, and this has come from parallel axis theorem. So now Ixx1 is the MI of rectangle number 1, which is here, about the x axis of unequal I section, that is in red, this x axis. So I will be calculating the MI for this first rectangle about this horizontal axis, and for that, as I can see, for the first rectangle, its x axis, I'll call it as 1 1, will be at half of 115, that is from the top. If I take this distance, this would be 115 mm, and the x axis for section 1, it is located at 82.17 mm distance from the top. So here there is difference between the two axes, and this difference is nothing but h1. So we have to use parallel axis theorem here, and for that I have written Ig1. Ig1 is the MI for section 1 about its own x axis, that is 1 1. So here I'll write down, therefore Ig1 is BD cube by 12 plus area 1 is B into D. Now what is H1? H1 is 82.17, here it is 82.17, and this distance, it was not 150, it is half of 115, because total is 115, so half of that. So here I have 82.17 minus half of 115 square. So therefore Ixx1 is equal to, now for the first rectangle, B is 10 and D will be 115, because this total distance is 115. So BD cube by 12. So 10 into 115 cube by 12 plus area 1 is 1150. Then here we have 82.17 minus 57.5 square. So if I calculate this throughout, I'll get the answer of Ix61, which is 1.969 into 10 raised to 6 mm raised to 4. Now after getting Ix61, I'll say that similarly mi about x-axis of unequal angle section for rectangle second, or we can say section second, one and the same, is given by Ix62 is Ig2 plus area 2 into h2 square. This is again by parallel axis theorem. So now if I can show it on the diagram, then here as we see, the x-axis for rectangle second, it is at 5 mm distance from the bottom, whereas the x-axis of complete unequal angle section is at 42.83 mm from bottom. So there is difference between the two axes, and that difference is called as h2. I can project it here. The difference between the two axes is h2. So therefore Ix62 will be equal to Ig2 is the mi of second rectangle about its x-axis, so it is BD cube by 12. Area 2 is 75 into 10, which is, I can write down first, B into D. Then H2 is 42.83 minus half of 10 square. So I'll go on putting the values. Here B is 75, D is 10. So therefore Ix62, it comes out to be 1.079 into 10 raised to 6 mm raised to 4. Once we have got Ix61 and Ix62, we can put their values in equation number 3. So therefore put Ix61 and Ix62 in equation number 3. So hence Ix6 is equal to, Ix61 was 1.969 into 10 raised to 6, Ix62 1.079 into 10 raised to 6. After adding them, my answer is 3.048 into 10 raised to 6 mm raised to 4. So this is our third answer, that is after x bar and y bar. This was the third case. Now as we have calculated Ixx, that is moment of inertia for unequal angle section about its x-axis, now we will calculate the value about y-axis. So I'll say that since mi for unequal angle section about its y-axis is given by Iyy is equal to Iyy1 plus Iyy2. keeping this as the fourth equation. Now we need to know what is Iyy. So I'll say that therefore Iyy is mi for rectangle 1 about y-axis of unequal angle section, that is given by Iyy1 is equal to Ig1 plus area 1 into h1 square by parallel axis theorem. Now if I can see in the diagram that the y-axis of unequal angle section is 17.83 mm from left hand side, whereas the y-axis of rectangle number 1 is at a distance of 5 mm from left hand side. So here we have the distance between the two axes, and when there is distance it would be called as h1, and here we have to use parallel axis theorem. If the y-axis for section 1 and y-axis of unequal section would have coincided, then there was no need of parallel axis theorem. But since here there is some distance, we have to use parallel axis theorem. So now here again we are using parallel axis theorem, and as we can see there was distance between the y-axis of rectangle 1 and the given unequal angle section, which distance was h1. So here first is Ig1. Ig1 is the mi of rectangle 1 about y-axis, that is its own y-axis here. So for that b is 10 and d is 115. So therefore Iyy1 is db cube by 12, area is b into d, h1 it is 17.83 minus, from this 17.83 if we subtract 5 mm, then we will get this distance h1. 17.83 minus this distance is 5, so 17.83 minus, I'll write down half of 10 square. So therefore Iyy1 will be equal to, here for the rectangle number 1 d is 115 and b is 10. Here this is 5. So if I calculate Iyy1, my answer comes out to be the value is 198.88 into 10 raised to 3 mm raised to 4. Now in a similar manner we will calculate Iyy2. So Iyy2 will be equal to Ig2 plus area 2 into h2 square, again by parallel axis theorem. So therefore Iyy2 is Ig2 db cube by 12 plus area is b into d. Now h2, what is h2? If I look into the diagram, for the second rectangle which is here, now its y-axis will be at half of 75, that is at 37.5, but the x-axis of the y-axis of unequal angle section is at 17.83 mm distance. So if I project this, that is the y-axis of rectangle number second, its distance is half of 75, that is 37.5, and from that if I subtract 17.83, I'll get distance as h2. So here this is h2 distance. So therefore we have 37.5 minus 17.83, that is 37.5 minus this value will give us h2. So here therefore Iyy2 will be equal to d and b values for the rectangle. If we see second rectangle, d is 10, b is 75, so 10 into 75 cube divide by 12 plus area is 75 into 10, then h2 is 37.5 minus 17.83 square. So from this I'll get Iyy2. My answer is 641.74 into 10 raised to 3 mm raised to 4. So after getting Iyy2, we will put the values in equation number 4. So therefore put Iyy1 and Iyy2 in equation number 4. So therefore Iyy will be equal to Iyy1, it was 198.88 into 10 raised to 3, Iyy2 641.74 into 10 raised to 3. Adding these values gives us the answer as 840.62 into 10 raised to 3 mm raised to 4. So this is our fourth answer. So now if we look into the question, there were 4 things asked for us. First, to get the location of centroid, and that we have calculated by finding x bar and y bar values, located the centroid. That was the first question. Second thing, we had to calculate moment of inertia about x-axis axis. Ixx, we have found out the value 3.048 into 10 raised to 6 mm raised to 4. And next, to calculate mi about the y-axis, and that was 840.62 into 10 raised to 3 mm raised to 4. And with this we complete the problem.